One.
The real growth of a country is in heart, minds, bodies and souls of young men and women of the country, said by Sir C.V. Raman. Good morning to everyone present here. Today, we all have gathered here to celebrate the National Science Day that is held on 28 February every year. This day marks the discovery of the Raman effect by Indian physicist Sir Chandrasekhar Venkat Raman. He was awarded the Nobel Prize in Physics in 1930. Every year, India celebrates this day to widely spread a message about the importance of science used in daily life of people. I, Disha Prakastha, take this privilege to warmly welcome all our delegates, all HODs, professors, faculty members, students of various departments, and everyone gathered here for the program. First of all, let me call upon the delegates on the dais. I request Dr. Dipankar Kaur Sir, Director of Ramanuj Gupta Degree College, to take his seat on the dais. I request Dr. Anjana Bhattacharjee Ma'am, Principal of Ramanuj Gupta Degree College, to take her seat on the dais. Light is the spark of joy, happiness, love, and the unchanging state of internal peace. We each have our own light, so no matter what challenges might arise, we must step into the light and move forward. On this spot, I request our delegates to come forward and light the lamp of eternity and also offer some flowers to Sir C.V. Raman as a sign of respect. I also request Head of Department of Physics to please come forward for the lighting of the lamp. I request a student representative of Physics Department to please come forward for the lighting of the lamp. Rupankita Roy Chaudhary, please.
Please come forward for the tribute.
Now I call upon the head of physics department, Dr. Shubhashish Chakrabarti, to brief us about today's program.
Hello everyone. Hello. Respected Director Sir, Principal Madam, all my colleagues and my dear students. So, first of all, I welcome you all to the National Science Day celebration organized by the Department of Physics RGDC. So, this program, as we know, it pays tribute to the great mind, Sir Chandrasekhar Venkatraman. But also, the way we have organized the program, it will be an enlightening process, or rather, learning process for our students. Okay, so it's a moment of great pleasure and pride that we have been able to organize such a program. Okay, so first of all, let me briefly mention the program schedule. So we'll start with the seminar session, the student seminar, which will be followed by the inauguration of our first ever wall magazine, TARANGA. We are very excited about that. And finally, we'll finish the session with poster and exhibition session. So the poster session will be held at Physics Lab 2. Okay, so I'll expect or request everyone to be present there. Okay. So we know that in the present era of science, it is important to present ourselves so that we can convey what we have done, our new and innovative research, to the general audience. And we should be able to present our works in such a way that it can be understood by audience of different levels of understanding. Okay, and I'm sure that this program will be the first step in that direction. Okay, and I can assure you that the Department of Physics will organize many more such programs in the upcoming years. Okay, now, so many of you are giving presentations for the first time, so there will be shakiness. You'll have stage fright, but that's all right. That's the starting process. You have to start from somewhere. Okay, so I cannot wait to listen to you all. Okay, thank you very much, and let's have a extra like intro. Yeah, thank you.
Thank you, sir. I request Director of Ramanuj Gupta Degree College, Dr. Dipankar Kaur sir, to please speak a few words.
So very good morning to all of you. At the very outset, I express my deepest sense of honor and gratitude to the great soul in the world of science of our country. And he's not only a scientist of our country, he's a scientist of the world, as you know that, because of his harmony factor. I'm very happy to see that this National Science Day, for the first time, is going to be observed or celebrated in our college, and that is the initiative of the physics department. And I have always a great kind of confidence about this department because it is marked by the presence of 4 very potential teachers led by the head of the department, Dr. Subhashish Chakraborty. And I know that these 4 teachers are the storehouses of different potentialities, and they really do have much kind of dedication to the subject. And they know how to make the student aware, how to make them updated in this particular subject. I have come to know from many students that because of the contributions made by these teachers, sometimes students of physics or even those who have physics past subject or except honors, they are very comfortable in understanding every aspect of the subject, and it is definitely because of the great kind of excellency your teachers do have. So on the National Science Day, it is a very pertinent duty for all of us to give a warm round of applause to those 4 teachers who are doing up this particular job. Dear students, actually, what is important today is the intimate kind of relationship in between the teacher and the student. And the way in which Subhashish was speaking out to you, it really gives me a kind of impression that you people do have a very intimate piece of relationship, and that is the main point of growth of a particular subject. That is, the student-teacher relationship should be very friendly. And this is what I observed today on this day. You know that Ramanand Gupta Degree College has come up with Science Stream only in 2019. And now it is just the beginning of 23. And within 22. And within this period, you'll see that this particular college has really created a benchmark in respect of imparting quality education in science. We started in a very humble manner in 2019, just with 27 students, 28 students, and now we have actually total of science, arts and commerce, total of 596 students. So this is the tremendous growth, and perhaps because of the opening of science, the stakeholders do have some kind of more expectation from us. And the way in which the initiatives are being taken, I'm sure that in the coming days, it will really create a kind of indelible impression in the mind of the stakeholders so far the imparting of quality science education is concerned. I should not say anything about this particular day, as you know that it is on this day, 28th of February, if I am not mistaken, 1928 perhaps, C.V. Raman actually came up with this particular Raman effect theory. And you'll see that immediately after that, 2 years, 1930, he got Nobel Prize in Physics. And you see that he is an iconic person in the world of science and research in our country. And that is why Indian Council of Research and Technology actually took the decision to observe 28th February as the National Science Day every year, and it began in 1986. So this is what, this kind of observation of the day started in 1986. And since then you see, this particular process is continued. Today as I come to know that this particular day is with a theme given by Dr. Jitendra Prasad, and he has suggested a theme of science and technology for sustainable development. Is it, Subhashish? So that is what I have come to know, because before coming here, I just made a kind of search to find out the actual significance of this particular day. So this is what I have come to know and I am sharing with you, and perhaps many of you also know this particular thing. And I am sure the kind of programmings today that has been made, it will definitely give a kind of demonstrations of the initiative of the teachers as well as the potentialities of the students through the presentation of seminar, through posters, and definitely there will be reflections of the creative bent of mind of the students when the release of the wall magazine Tarang will take place, or Taranga will take place. So this is for the first time in the history of Ramanuj Gupta Degree College, a department has come up with a wall magazine. I would love to request you to fix a time duration, whether it should be bi-monthly or whether it should be half-yearly or whether it should be annually. You think as per your convenience, because you must remember that there is a tremendous pressures of CBCS semester examinations and all that, and there is no particular schedule of the examinations. So I don't think that frequently you can come up with this. That will also create a problem for the students to come up with their creative writings. So think, the departmental people should think wisely. They should interact with the students and take a decisions and to see that what could be the type of this particular journal. And I'm sure that all the teachers of physics department will take every care to publish this wall magazine almost regularly as per the time fixations. So with all these things, I first of all love to wish all the paper presenters a good success. Those who will come up with posters, again they will definitely create a kind of impressions, and you will get proper evaluations from your very erudite teachers of the department. They will judge it and they will give their comment on the posters, and definitely Tarang will give a reflections. And I'm sure today on this National Science Day, college is very fortunate because our MP Dr. Rajiv Rai is coming to college at about 12. I'd love to request our head of the department, Dr. Subhashi Chakraborty, to at least defer the program of opening of wall magazine. So let him come and let this particular wall magazine see the light of the day through the hands of another vibrant man of science, because he was a student of science. He's a very well-known orthopedic surgeon, and he was a very brilliant student in GC College while I was there. In 1991, he was in science as a science student, and therefrom he got medical, that is opportunity in medical science. So I'm sure that a right person is coming today on this National Science Day. So let me request the physics department to at least take some initiative so that the wall magazine can see the light of the day through these hands. Thank you so much. Wish you every good luck to everyone.
Thank you, sir. I request Dr. Anjana Bhattacharjee ma'am, Principal of Ramanuj Gupta Degree College, to enlighten us with few words.
A very good morning to all of you. Science Day, National Science Day, সবখানে মানানোই হয় এই জন্য যাতে ইয়াং স্টুডেন্টসরা ঠিক ওই রকম ভাবে উঠে আসতে পারে। আর এমন একটা হয়তো দিন আসবে যেদিন হয়তো এর তোমাদের মধ্যে থেকে কেউ এমন একটা কিছু ডিসকভার করে দেবে যেটার জন্য we will feel proud of. সবচেয়ে যেটা আমার ভালো লেগেছে তোমাদের মধ্যে স্টুডেন্টসদের মধ্যে এনথুটা দেখে, কালকে পরশু দেখছিলাম তোমাদেরকে দিয়ে করাতে হচ্ছে না, তোমরা নিজেরা করছো। দ্যাট ইজ দ্য বেস্ট থিং। টিচাররা তো সঙ্গে আছেই, অনেক সময় এরকম হয় টিচারদেরকে করাতে হয় কিন্তু তোমাদেরকে দিয়ে করাতে হচ্ছে না, তোমরা নিজেরা করছো। দ্যাট ইজ দ্য বেস্ট থিং। তোমাদের এই প্রোগ্রামটার জন্য বেস্ট উইশেস তোমাদেরকেও, ডিপার্টমেন্টকেও। আমাদের জন্য সত্যি এটা আজকে খুব একটা কি বলবো, একটা আনন্দেরই দিন যে এই ডেটা আমরা এইভাবে সেলিব্রেট করতে পারছি। আরো আগামীতে নিশ্চয়ই আরো আমরা সেলিব্রেট করবো এইভাবে, আরো তোমরা এগিয়ে আসবে। যারা এখন ফার্স্ট সেমিস্টারে আছো তারা আস্তে আস্তে, এখন যারা ফিফথ সেমিস্টারে আছো তারা তো আর কিছুদিন পর বেরিয়ে যাবে, কিন্তু এটার ইম্প্যাক্টটা হয়তো তোমাদের লাইফে থেকে যাবে। তোমরা যখন মাস্টার্স করবে তখন হয়তো তোমাদের লাইফে এই জিনিসটা থেকে যাবে। এই আমি যদিও সায়েন্সের স্টুডেন্ট নই, আমি আর্টসের স্টুডেন্ট, কিন্তু দেখেছো আমাকে মহাকাশ দেখতে প্রচন্ড এক্সাইটেড যার জন্য আই নেভার কাম সো আর্লি টু কলেজ বাট এটা শোনার জন্যই আজকে আসা আর কি তো অল দ্য বেস্ট থ্যাংক ইউ
Thank you, ma'am. It's time to begin with the seminar. As this seminar is built with intent of active and interactive learning, we sincerely hope that ideas and views shared during the seminar will sow its seeds for a fruitful learning.
একটু ল্যাগ করছে ওটা মানে 2 মিনিটস পর মানে
Hello.
The first one to present a seminar on the topic number system is Shayan Datta. I request him to please come forward.
Good morning to one and all present here, most respected Director Sir, Principal Ma'am, my teachers, my seniors and all the public present here. Today on the auspicious occasion of National Science Day, I, Shayan Datta, student of 3rd SEM, present here to say a short seminar on the topic number system, its type and its conversion. So everybody knows number system is what? What are numbers? It's a class 4-5 question. Everybody knows it. So my first type, sir, as we have grown up, we started knowing that there are many types of number system. There are multiple types of number system. So out of this multiple types, we will just discuss any 4 types of number system. So let's start with the first. So according to the topic, there are 4 types of number system. One is your decimal number system, binary number system, octal number system, and hexadecimal number system. So let's begin our topic with the binary decimal number system. Decimal number system, all of you know, are the type of number system that will take 10 as the base and the digits are from 0 to 9. We will consider in case of decimal number system that the base of the decimal number system will be 10 and the number of digits that will be counted will be from 0 to 9. So let's for the better explanation or for better understanding, let's have an example to clear it out. So let's have an example. But before I go for some example of decimal number system, let me say one thing, that one of the key points that need to be followed during the conversion, that each successive position to the left, any successive position to the left is 10 times greater to the immediate right. That means the digit, if it is 10 to the power 5, then the previous, before 10 to the power 5, it will be 10 times, that is 10 to the power 4. So 10 times the difference will be, successive position will be 10 times greater. So let's see an example. Suppose the decimal number system is 5704. So first of all, we all know that every number systems are positional number system. We consider all the number systems are positional number system. So the place value, since I have already told the base is 10, so it will be 10. So here the number is 5704, counting from the immediate right. That means there are 0, 1, 2, 3. So total 3. So that's why the position started from 3, 2, 1, 0. So let's, in place of 3, it will be 10 to the power 3. Why? Because the place value is 10. The base is 10. So 10 cube. Then in case of 2, it will be 10 square. Then again in case of 1, it will be 10 to the power 1. And then in case of 0, it will be 10 to the power 0. Now we will plot the plot the value that we have mentioned in the question. That is 5704. Now, accordingly, by using our general mathematics, we will just calculate the value 4 into 10 to the power 0. Then the next value comes, that is 0 into 10 to the power. Why 10? Because we have considered 10 as the base in case of number system. Then the 7 into 10 to 10 square, because the power is 10 square. Then 5 into 10 cube, and the value is come, and the required sum comes. That is the question 5704. Please next. So now, according to the topic, after decimal number system, it comes about binary number system. So binary number system are the type of number system that has base 2. We consider 2 as the base. 2 as the base. As we have earlier told that in case of decimal number system, we take 10 as the base, and now in case of binary number system, we take base as the 2, and number of digits are 2, 0 and 1. In case of binary number system, we take digits as 0 and 1. And earlier that I have discussed that in case of decimal number system is 0 to 9, but in binary number system we have 0 and 1. Let's understand it by proper example. Again I have told that in case of decimal number system, we have told that 10 is taken as the immediate right, 10 times greater than the immediate right. So here, each successive point in the integer part in the binary number has the value 2 times greater. Yes, earlier we have discussed that 10 times greater than the immediate right. Now I am going to discuss that the base will be 2 times greater than the immediate right. Let's have an example so that we can have a better explanation. So I have taken a value, the binary number is 1101. Why 1101? Because in previous slide only I have explained that the number of digits will be 0 and 1 only. We all know that for binary it will have 0 and 1. So let's have the value 1101. So how many? 1101 means 0, 1, 2, 3. So 3. So position value will start again from 3 to 10. 0, 1, 2, 3. From immediate right it will start from 0, 1, 2, 3. So let's take the value first. So in case of 3, it will be 2 cube. Why 2 cube? Because in case of binary number system, we take value 2 as the base. Then it is 2 square. Then 2 to the power 1. Then 2 to the power 0. According to the table. Now let's take the binary points according to. So what was the question? 1101. So under 2 cube it will be 1. For 2 square it will be 1. Again for 2 to the power 1 it will be 0. And then for 2 to the power 0 it will be 1. So by according to this manner only we can solve any kind of binary numbers. That's the interesting. Most of the 50% people know about decimal and binary, but there are many that even I also started learning about octal and hexadecimal after coming to the graduation. So let's start learning about a bit explanation of octal number system. Octal number system are what? By word octal we get a playback that maybe octal is 8. We call it 8 as an octal. So we will take base as 8 and the digits are from 0 to 7. As for binary also we have told 0 and 1 are the 2 digits for binary. But in octal case we will tell that digits are from 0 to 7. As in decimal also we told 0 to 9. So in octal also it will be 0 to 7. Let's have an example so for the better explanation please. Okay, let's first go for hexadecimal number system. Hexadecimal number system here, one of the interesting point is 16 is taken as the base. As you don't know that in case of hexadecimal number system we take 16 as the base, and the most interesting concept is first 10 digits, first 10 symbols are represented by digits. Yes, first 10 symbols are represented by digits, that is from 0 to 9, and since it is 16, it is hexadecimal 16, so the rest 6 is represented by alphabet, that is A, B, C, D, E, F, which means A will be equal to 10, B will be 11, C will be 12, D 13, E 14, F 15. Because earlier we have told that digits are from 0 to 9 and the rest 6, since it was 16, hence the remaining 6 is represented by alphabet that we have done. Let's have an example. Suppose here also we have taken an example 1 to AF. If you take an example of 1 to AF, so 1 to AF is here total 4 digits starting from 0, 1, 2 and 3. So in case of value we put since it was the base 16, we can consider hexadecimal as the base 16. So it is 16 cube, then for 2 it will be 16 square, then for 1 it will be 16 to the power 1, then it will be for 0 it will be 16 to the power 0. Then hexadecimal point will be according to the question that 1 to AF we have plotted. Then we have done a similar small mathematical calculation and last the value that comes is 4783. Which can also be represented in hexadecimal form. Conversion of binary to hexadecimal. Now we have almost learned about octal, hexadecimal and all. Now let's know how the conversion take place. That was the last. I think I have already said that there will be conversion. So how the conversion will take place? So in order to convert a binary number to hexadecimal, binary number means what? 1 and 0. 1 and 0 is taken as the binary number. So in case of binary number, in order to convert binary number to hexadecimal number, it is necessary to group the binary digit in set of 4. Yes, one of the key points that we have to need to follow is to first, in order to convert, we will just make a group of 4 before conversion and convert each group to its hexadecimal. After making it in a pair of 4, we will convert each 4 to its equivalent hexadecimal. Let's have an example. Suppose an example of 0, 1, 1, 1 like this as written in the question board. It is written. Now we will group the digit in case of 4. So I have already done it. The 0, 0, 1, then 1, 0, 1, 0, 0, 0, 1, then 0, 0, 1, 0, then 0, 0, 1. Now, according to it, by plotting, we will get to know the hexadecimal point. Hexadecimal point in case of 0, 1, 1, it will be 7, then 1, 0, 1, 0, it will be 0, 0, 1, it will be 1, 0, 0, 1, 0, it will be 2, and 0, 0, 1, it will be 1. So the required will become 7A1 to 1. So, how to convert binary representation to octal numbers? How we will convert? What is the point? Means how can we convert? So, if the octal representation is 0, the binary equivalent will be 0, 0, 0. If the octal representation is 1, then it will be 0, 0, 1. Then if the octal is 2, then it will be in binary, we will explain it 0, 1, 0. If it is 3, then it will be 0, 1, 1. If it is 4, then we will explain 1, 0, 0. 5, it will be 1, 0, 1. 6, it will be 1, 1, 0. And the 7, it will be 1, 1, 1. Key points to be followed during conversion of octal to hexadecimal. So, what are the main key points that we have to keep in mind during the conversion of octal to hexadecimal? First of all, write the octal number because we have to convert this. So, first we have to write the octal number, place the binary equivalent of each digit below the number. Yes, after writing the octal number, we will place the binary equivalent, the binary number as in the previous slide only I have told you about in the table that how can be represented. So place the binary equivalent of each digit below the number, regrouping them as the binary quadruplets. Yes. Then after writing the binary equivalent of each digit, we will plot a binary quadruplets. Means we will pair it in the group of 4 quadruplets from the binary points with 0 added if necessary. If required, we will add 0. Number 4, convert each group with equivalent hexadecimal. Means after the 4 pairing, we will convert each to equivalent hexadecimal. So an example of this conversion. Suppose we have taken a conversion of octal number 243 to hexadecimal. Here, binary is what in the previous 2 slides only I have explained that what are the binary equivalent of octal numbers. So binary equivalent of 2 it will be 0, 1, 0. Binary equivalent of 4 it will be 1, 0, 0. And binary equivalent of 3 it will be 0, 1, 1. These are what? These are binary points. Now let's regrouping them as the binary quadruplets. Let's regroup them as the binary quadruplets. In the pair of 4 as I told 0, 0, 0, 0, 1, 0, 1, 0 and 0, 0, 1, 1. Now according to it we will plot the values. It will be 0, A3. It will be 0, A3 and the 243 base it will be A316. Key points. Now last the key points is to convert hexadecimal to octal number. How we will now, as I have learned octal to hexa, now let's have a hexadecimal to octal number. A 16-bit, how can it be converted to 8-bit? So write the hexadecimal number first. We will put the hexadecimal number, place the binary equivalent of it. Yes, after writing the hexadecimal, we will plot the binary equivalent of each digit, regrouping them as the binary triplets. But in previous slide only I have told that we will group them as 4, but now in this case we will group them as 3 and convert each group into its equivalent octal. After grouping it into 3, we will convert each group into its equivalent octal digit. Let's have an example, conversion of 39.B8 to octal number. Hexadecimal point, let's start with hexadecimal point is 39B8 as in the question. What is the binary equivalent? Let's write first binary equivalent. Binary equivalent 00111 of 9 is 1001, for B is 1011 and the 8 is 1000. Now let's regroup as the binary triplets. We will group it as the binary triplets. So it will be 000, then again 111, then 001, then 101, then 110, then lastly it will be 000. Octal points, then as the pairing according to the pairing of the binary triplets, we will put the octal points according to it. So 071560. So here we can say 39.B816 can be written as 71.560. So this is how we can convert. Thank you so much for giving me a special opportunity and a special
Question session. Question session.
Any questions can ask please. If you have
If there is any question, you can ask.
Okay, thank you.
Is there any question?
Thank you, Shayan Datta, for such a detailed explanation of number system. Next, I call upon Jibodip Paul, Shupratik Dev and Himashish Das to present their seminar on the topic Chandrayaan Mission to Moon.
Good morning everyone. I am Shupratik Dev. I am Jibodip Paul and I am Himashish Das. Today we are here to give a small talk on the missions of Chandrayaan. So we always have a curiosity, why go to moon? What's there on the moon? So in the upcoming slides, we will know about some of the discoveries that our Indian scientists had made a glorious legacy. Next slide please. So Chandrayaan. Here Chandrayaan means mooncraft. All you need to know about Chandrayaan 1 is that it was India's first lunar unmanned mission that had left a glorious legacy, and it was the first missions of ISRO that which have become after the Chandrayaan 2 and Chandrayaan 3. Next slide. So Chandrayaan 1 was launched on 22 October 2008 from Satish Dhawan Space Research Center, Sriharikota. And as you all know that it was first lunar space mission from Indian Space Research Organization. And the end mission of the Chandrayaan 1 was 28 August 2009. So on 14 November, the Moon Impact Probe that separated from the Chandrayaan 1 spacecraft and got stuck on the south pole of the Moon. And thus, India became the fourth nation to place its flag on the surface of the Moon. Here, Chandrayaan 1 spacecraft was PSLV XL, and the spacecraft that was known after the meteorological base, which name was Kalpana satellite. So these are the few objectives of Chandrayaan 1. The first is that to determine the simultaneous mineralogical, chemical and photogeological mapping. Secondly, high resolution mapping of the lunar surface to identify mineral. 3D mapping of lunar surface at very high spatial resolution, and also to motivate the young minds to space and planetary science. So the achievements of Chandrayaan 1. The discovery of presence of water molecule on the lunar soil. Chandrayaan 1 also confirmed that the moon was completely molten once. So Chandrayaan 1 also recorded the landing site of Apollo 15 and Apollo 11. As you all know that Neil Armstrong was the first man to step on the moon. A spacecraft used by Neil Armstrong was Apollo 11. So the major discoveries of Chandrayaan 1 was the detection of water and hydroxyl on lunar surface. The data also revealed their enhanced abundance towards the polar region. Next, moving on, next topic is Chandrayaan 2, which will be presented by Jibodip Paul.
Thank you, Shupratik. Now I am going to talk about the mission Chandrayaan 2. So, first we talk about the introduction of Chandrayaan 2. As the Chandrayaan-2 mission was the India's second moon mission, launched on 22nd July 2019 by geosynchronous satellite launch vehicle Mark 3 M1, shortly called as GSLV Mk3 M1 spacecraft. And this picture shows the GSLV spacecraft, where this yellow part shows the three basic modules of our mission, and these are the covers where the fuels are there. So moving to the objective, that what is the main objective of the mission? So the primary objective was to develop and demonstrate key technologies for end-to-end lunar mission capability, including soft landing and roving on the lunar surface, and to pursue lunar science studies, water identification or mapping, and mapping of surface composition. Also, it mainly aims to explore the moon's south polar region. Now, this picture shows the lander, one of the three modules, the lander of the mission, named Vikram, after Dr. Vikram S. Sarabhai, the father of India's space program. So, please next slide. Now, moving to the mission profile. Firstly, Chandrayaan-2 spacecraft, as I said earlier, Chandrayaan-2 spacecraft consists of three modules, namely orbiter, lander named Vikram, and rover named Pragyan. Now, talking about the payloads of the mission. So, firstly, about orbiter payloads, which are TARANGA camera, Chandrayaan-2 and Chandrayaan-2 area soft X-ray spectrometer, which measures the moon's X-ray fluorescence spectra, which is used to examine the availability of elements like magnesium, calcium, titanium, etc. on the lunar surface. Moving to next payload, which are radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, shortly known as RAMPHA, RAMPHA, and Chandra's surface thermophysical experiments, which aims to detect, find the information about the temperature coefficient or temperature gradient and density of moon surface. So, please next slide. Now, lastly, moving to Pragyan payload, which are alpha particle X-ray spectrometer and laser-induced breakdown spectroscope, which is used to find the abundance of elements on the landing site where the spacecraft lands. And this picture shows the basic three modules. It is rover, Pragyan rover. This is the orbiter, and this is the structure of the Vikram lander. The next slide, please. Now, this is how the spacecraft goes to moon from Earth. So basically, we know the average distance of moon from Earth is 3,84,400 kilometers. So, if we follow the shortest path from Earth to moon, then it takes, with a speed of escape velocity, which is 11.2 km per second, it takes only 9.5 hours to reach there. But to make the mission less costly, our scientists designed less powerful engine so that the rocket took the spacecraft in a highly elliptical parking orbit and then slowly increases the distance from Earth by accelerating its speed, and then when the moon reaches, when the spacecraft sufficiently reaches closer to moon, it enters the moon's orbit and then performs the mission. And after that, as it is written there, the lander orbiter pair went to an initial as it is written there, the lander, after the spacecraft enters the moon's orbit, the lander orbiter pair went to an initial elliptical Earth orbit followed by a translunar injection, and then after orbit insertion, the lander and the orbiter separate. So next slide, please. Now, lastly, the rover and the lander of the mission has a life of 1 lunar day, which is equal to 14 Earth days. To the orbiter has a life of 1 year. The orbiter, which is one of the three modules, has a life of 1 year, but the lander and the rover has a life of 1 lunar day, which is equal to 14 Earth days. So next slide please. Now moving to the landing results, which will be explained by Himashish Raj.
Thanks, Jivadev. So, as we have already discussed about the mission profile of Chandrayaan 2, now let's get into the topic of landing results of Chandrayaan 2. So, unfortunately, a last-minute software glitch led to the failure of soft landing of Vikram lander on the moon surface. So, basically, the Vikram lander actually crash landed on the moon surface after its guidance software went wrong. So, basically, these are the spot on the moon surface where the Vikram lander actually crash landed. So, next slide. So ISRO basically designed the Vikram lander to do a soft landing on the moon surface and was supposed to analyze the moon's terrain and to send back data for a minimum of 14 days. Since during the training process the software was functioning well, but unexpectedly it failed due to a glitch after the launch. So basically this could be the scene if the lander would have landed successfully on the moon surface. And this could be the rover which would be setting up its wheels on the moon surface. Next slide please. So now if we discuss about the upcoming missions of Chandrayaan, the Chandrayaan 3. So next slide. So Chandrayaan 3 mission is actually a follow-up mission of Chandrayaan 2, which Chandrayaan 2 was July 2019, which aimed to land a rover on the lunar south pole. So ISRO is set to launch the Chandrayaan 3 in its most powerful vehicle called the GSLV Mark 3, just like as Chandrayaan 2, and it will actually be a mission repeat of Chandrayaan 2, but it will only include the the lander and the rover, and like Chandrayaan 2, it will not include the orbiter. So now if we just now talk about the budget of these two missions, we can just barely imagine the difference between the margins. So basically Chandrayaan 2 was worth of like 400 crores and Chandrayaan 3 is only of 75 crores. So we can barely imagine the difference between them. So these are some of the facts we stated about Chandrayaan and Chandrayaan 1 and Chandrayaan 2 and Chandrayaan 3, the missions of Chandrayaan actually. So, and we eagerly look up to your questions. So please feel free to ask any of your queries. Thank you. So any questions, anyone?
Any questions, madam?
Yeah.
Thank you.
What is the timeline of your Chandrayaan 3 launch?
Chandrayaan 3 timeline. Means when will the mission?
When the mission will start or?
It will basically means it's not fixed. So the scientists just actually like
Set a date we have at end of 22 or 23.
actually on August 2020.
Okay. Thank you.
Well,
Thank you, Jivadev, Supradeep and Himashish for such a nice presentation. Now I'd like to call upon Sneha Tiwari and Preeti Sinha to present their presentation on spectroscopy. A very good morning, Honorable
internet connection.
A very good morning to my honorable teachers, my dear seniors, my classmates and my fellow juniors. I am Pidrani Sinha from 3rd semester physics major.
And myself Sneha Tiwari from 3rd semester physics major. And we are here on the auspicious day of National Science Day to present a short seminar on the topic spectroscopy. So, before talking about spectroscopy directly, let us first have a look onto its history. So, Sir Isaac Newton back in 1665 took the first and the most important step toward the development of spectroscopy. He showed that when a white light passes through a prism, it breaks into 7 different component colors. He is also known as the discoverer of spectroscopy. So, now coming back to spectroscopy. So, what is spectroscopy? Spectroscopy refers to the study of interaction of matter with electromagnetic radiation. That is, this matter can be atoms, ions or molecules, and the electromagnetic radiation has both electric and magnetic fields which vary simultaneously. The spectroscopy is used as a key tool for studying the structure and the function of atoms and molecules. Now let us have a look. Since we talked about the electromagnetic radiation, let us have a look on what electromagnetic radiation is.
So what is electromagnetic radiation? Electromagnetic radiation is a type of radiation that have both electric and magnetic field perpendicular to each other. Now electromagnetic spectrum is generally divided into 7 radiations in order of increasing frequency and intensity and decreasing wavelength. So what are the 7 electromagnetic radiations? They are radio waves, microwaves, infrared, visible, UV, X-ray and gamma. Now these radiations have their own electric field and magnetic field that vary simultaneously. Now this is the wavelength given for visible light, that is from 400 nanometer to 700 nanometer, which can be seen by our naked eyes. Now you will be thinking about what spectrum is. What spectrum is?
So, a spectrum is a continuum of color formed when a beam of white light is dispersed so that its component wavelengths are arranged in order. Example is a white light passing through a prism. So, when we shine a white light on a glass prism, it breaks into 7 different component colors. This band of color, when a white light is splitted, is called the spectrum. The types of spectrum are absorption spectra, emission spectra, and continuous spectra. The example of continuous spectra is what we have seen just now, that is the white light passing through the prism. It is called continuous because all the 7 colors are merged among themselves. That is, the violet merged into the blue into green, and so on. Now let us have a look on what absorption spectra is. So, an absorption spectra is a continuum of radiation is passed through a sample of a gas which absorbs radiation of certain wavelength. Let us have a look on a video so for a good assumption. Here is the light source, a cloud of gas, slit, prism, and a film or detector. Light from the light source falls on the cloud of gas, passes through the slit, and falls on the prism. Here dispersion is taking place, and hence the spectrum is formed on the film or detector. This spectrum is the absorption spectrum. Here is the spectrum, and as you can see, there are dark lines or gaps, which means some of the wavelengths are absorbed by the gaseous spectrum. This was all about absorption spectra. Now let us have a look on emission spectra. So, the spectrum of radiation emitted by a substance that has absorbed energy is called the emission spectra. Here is the hot sample. Energy is supplied to the hot sample by passing electric current. Here is a slit, prism, and a film or detector. Light from the hot sample passes through the slit and falls on the prism. Here dispersion is taking place, and hence the spectrum is formed. As you can see, the spectrum has bright light on the dark background. That is, it is corresponding to the wavelength that has been released. Now, this was all about the emission spectra. Let us see some types of the absorption spectra. So, as of now, we will know that spectroscopy is of 2 types, absorption spectra and emission spectra. The absorption spectra is divided into UV spectroscopy, IR spectroscopy, and NMR spectroscopy. The emission spectra is divided into fluorometry and flame photometry. Today we are going to discuss some of the types of absorption spectroscopy. So starting from UV spectroscopy.
So let us elucidate UV spectroscopy. When the ultraviolet or visible light in the electromagnetic spectrum passes through a sample or gets transmitted through the sample, its intensity decreases. The measurement of this attenuated intensity is called UV visible spectroscopy. Thus, it can be said that it is the measurement of the attenuation of a beam of light passing through a sample or after reflection from the sample surface. So let us see some uses of UV visible spectroscopy. UV visible spectroscopy is one of the best methods for detection of impurities. It also helps in RNA and DNA analysis. It is extensively used in the detection of functional group, thus it can detect the presence or absence of a functional group in a compound. So the next topic is infrared, which will be explained to you by Sina.
So please play the video. As we all know, Newton has shown us that when a white light passes through a glass prism, it breaks into 7 different component colors. So there was another scientist called William Herschel who wanted to know the relationship among the 7 different colors. So he placed a thermometer on each color, that is one in blue, one in violet, one in green, and so on. So just for checking the room temperature, he placed another thermometer right after the spectrum to check the room temperature. Surprisingly, what he found that the temperature which was kept for checking the room temperature had the highest temperature. That is, this is when the infrared waves was discovered. So the spectroscopy that deals with the infrared region of the electromagnetic spectrum, that is the light with a longer wavelength and a lower frequency than the visible light. This was all about infrared spectroscopy. Now let us see about its uses. So, it is extensively used in forensic studies. For example, for paint analysis in a heat and burn case. It is used in study of a covalent bond molecule, and it is also used in quality product for perfume manufacture. Now, as we have talked about infrared spectroscopy, there is another spectroscopy which is considered to be complementary to the infrared spectroscopy, that is the Raman spectroscopy. So back in 1928, C.V. Raman was able to discover the Raman effect. Its official date was 28th of February, which is observed as the National Science Day, which is 5 years present here today. Now, let us have an introduction on the Raman spectroscopy. It is a spectroscopic technique based on the inelastic scattering of monochromatic light, usually from a laser source. Inelastic scattering of a monochromatic light means the frequency of the photon released from a monochromatic light changes upon the interaction of matter. Now let us have a detailed look up on what Raman effect is.
So let us explicate Raman spectroscopy. When a sample is exposed to a monochromatic light in visible region, the sample absorbs light.
and major portion of the light gets transmitted through the sample. However, a minute part of the light gets scattered by the sample in all the directions. Now the incident photon has some frequency. If the frequency of the incident photon is equal to the frequency of the scattered photon, then it is called Rayleigh scattering. And if the frequency of the incident photon is not equal to the frequency of the scattered photon, then it is called Raman scattering. Now let us understand Raman scattering. Raman scattering can be divided into two lines, Stokes and anti-Stokes. So how can Stokes and anti-Stokes can be observed? If the frequency of the incident photon is less than the frequency of the scattered photon, then anti-Stokes is observed on Raman spectra. And if the frequency of the incident photon is greater than the frequency of the scattered photon, then Stokes lines are observed on Raman spectra. And another thing is that the Stokes line is brighter than the anti-Stokes line because the number of atoms in ground state is more than the number of atoms in excited state. So let us see some uses of Raman spectroscopy.
So, Raman spectroscopy is extensively used in pharmaceutical industry. It is also used for the study of cell, and it is also used for identification of molecule. So, this was all about Raman spectroscopy, and with this we conclude our short seminar. Thank you.
Is there any questions?
Thank you, Sneha and Preeti. Now it's the turn of Moushami Das and Tanushree Roy to present a seminar on the topic gyroscope.
Take the other mic also.
That's what we do.
Good morning, everyone. Today I am Moushami Das and myself.
Switch on.
Switch
on off.
And myself, Tanushree Roy, we are going to talk about the topic gyroscope. So these are the topics we are going to talk about. So first of all, we will know what gyroscope is. Then we will know about the history of gyroscope. Then we will learn about the history of gyroscope, and we will also learn about the parts of gyroscope, the principles and properties of gyroscopes. And then we will end our talk by discussing about the applications of gyroscope. So in our childhood, we must have seen a spinning top. In Bengali, we call it eslatu. We must have also seen it spinning or rotating. Like in this picture, a kid is playing with a spinning top. So this is how we also used to play in our childhood with that. So this totally holds the properties of gyroscope. So if any metal wheel can be rotated in an axis, or we can say if we can rotate a wheel in an axis, then it can be called a simple gyroscope.
Next slide.
So now let us talk about the first gyroscope invented. This device has a spinning disc on a base such that it can move freely in more than one direction, so that its orientation can be maintained. So now we will see about the parts of gyroscope. So there are 4 parts of gyroscope. First one is gimbal, then gyroscopic frame, rotor and spin axis. So let's talk about the gimbal. This is the gimbal. So it accommodates rotation about multiple axes. Then gyroscopic frame. This is the gyroscopic frame. So it is mounted so as to pivot about an axis in its own plane. Then rotor. Rotor. This one is rotor. So it equals stability of balance at high speed rotation. Then spin axis. It is the this is the axle of the spinning wheel. So speaking about the history of gyroscope, it was first discovered, or you can say invented, discovered in the first half of the 19th century by the first French physicist Jean-Pierre Foucault. And it was first noticeable use. Its first noticeable use was in a visual demonstration of the Earth's rotation. So now let us know about the principle of gyroscope. On what principle does gyroscope works? So it is explained by the product of angular momentum, which is experienced by the torque produced by the gravitational field of the Earth. So if something spins, then if a wheel spins, it has angular momentum, which we denote as capital L. And this angular momentum changes depending upon the torque applied on it, and we denote the torque with the symbol tau. So now the main question is that what is the direction of the angular momentum? So to make it easier for us to determine the direction of the angular momentum, we use right hand thumb rule. So what we do is, if we curl our four fingers of our right hand in the direction of the spin, then we will notice that we will see that the thumb points in the direction of the angular momentum. So what we have on our case, let us say, what we have is a torque spinning in its axis in anti-clockwise direction. So if we spin our if we rotate, if we curl our four fingers of our right hand in the direction anti-clockwise direction like this, in anti-clockwise direction, then our thumb points in the upward direction like this. In the upward direction. So we can say that therefore the angular momentum is in upward direction. So like the angular momentum, torque has direction as well. So the direction of the torque is in the perpendicular to the direction of the plane of axis, plane of rotation. Speaking more about gyroscope, it has two fundamental properties. The first is gyroscopic inertia, also known as rigidity, and the second is precision. Let us get a brief idea of this art. What this art? Gyroscopic inertia. The name itself suggests a tendency to resist the change in state. Now consider a situation where there is no gravity. Let us take a top and suspend it in the ground. Initially it is not in motion, so it will trip off to the ground. Now, if we spin it, it will resist to change the direction of its axis of spinning and maintain its orientation in a fixed plane. Here, the brown stick indicates the axis of spinning, and similarly, the gyroscope spins about its axis. This is the property of gyroscopic inertia, where a spinning body resists to change the direction of its axis and maintain its orientation due to its angular momentum. But this was the case when no external forces are acting on the spinning body. What if, let us take into account the Earth's gravitational field. Due to it, an external angular force or torque is exerted on the spinning body, which leads to the change or tilting of the axis of spinning, and it traces the path of a circle. This phenomenon of slow rotation of the axis of spinning, which traces the path of a circle, is called precision. This was about the properties of gyroscope. What about the massive celestial bodies inside the gyroscope? Any spinning celestial body can be indeed considered a gyroscope. Speaking about the motion of the Earth, it is an axially symmetrical spinning body spinning about its own axis and is suspended in such a way that it rotates around the Sun in an elliptical orbit, and its axis is tilted at an angle of 23.5 degrees with the plane of elliptical plane. Part of the motion of the Earth is subjected to gyroscopic precession, also known as precession of equinoxes. with a period of 26,000 years. To understand better, currently the North Star is only approximately above the North Pole of the Earth. Due to precision, the Earth's axis tilts or changes its position, and in 13,000 years, it will be the axis will point somewhere totally different. And in 26,000 years or so, it will be back to where it is now. Hence, completing one cycle of 26,000 years. But we know for precision to occur, a torque is required. In the case of the Earth, the gravitational influence of the Sun and the Moon exerts a torque on the Earth. A part of the influence is also created by the other planets as well. This was about the precision of Earth or precision of equinoxes. Now, gyroscope is also used in our day-to-day life in different devices. So let us know about the practical uses of gyroscope. In motorboat, it is used to stabilize the boat by creating an energy from the spinning wheel at high revolutions per minute. In spaceship, the gyroscope senses the slightest change in the axis of rotation, hence stabilizing the spaceship. In unmanned air vehicles, the directional gyro resists to change its position and hence provides stabilization. In airplanes, the gyro senses the changes in the axis of rotation and hence provides stabilization in it as well. In gaming consoles, the gyro helps us to determine how and where to move the controller, as many of us here play games as well, we know. In robotics, the gyro helps in sensing the signals and send it to the computer, which acts as the brain for the robot. In motion sensing, in mobile phones, it is also used for motion sensing. That is, it makes us able to watch 360-degree videos and photos in our mobile phones or cell phones. In racing cars, it helps the car to balance on two wheels through its hood. So this was all about our talk about gyroscope today. Thank you for your valuable attention and time.
Any questions? Anybody?
Any questions?
I welcome Shri Shodagindu Dhod among us, sir. We'll move to the next speaker. I call upon Abhirup Chaudhary and Shaktideep Shah to present their seminar on the topic Li-Fi.
Hello everyone. A very good morning to respected teachers, to all my seniors and my classmates. Now, so I am Shaktideep Nath, this is Abhirup Chaudhary, and today we are going to discuss about a topic named light fidelity or Li-Fi. So the first thing that comes to our mind after listening to the word Li-Fi is actually Wi-Fi, because it sounds kind of similar. But are the two terms similar? Let us find out. So here are the outlines of the topic we will be talking today. So before moving on to the definition of Li-Fi, for your information, I would like to say that the current available radio spectrum which is being used to transmit data wirelessly is less than 10 GHz, and it has actually become insufficient due to the overuse of it, and saturation and leading to a phenomenon known as spectrum crunch. And a part of this is why everybody nowadays faces internet connectivity problems time to time. It really affects our flow of work, gives us unnecessary frustration and anxiety, and ruins our mood. So there is a need of a technology which uses a faster mode of transmission like light to transmit data. Here comes the concept of Li-Fi. So light fidelity is basically a visible light communication system where light becomes data and it transmits it in light speed. And in simple words, it is a light-based Wi-Fi.
Let's see the history of Wi-Fi. The term was first coined by Gerald Hurst in 2011 at Global Talks in Edinburgh, where he introduced the idea of wireless data for every life. He founded a company with Dr. Mustafa Afghani called Pure Wi-Fi to market it. In September 2013, the company released world's first commercially available Wi-Fi technology. Now let's see the working of Wi-Fi. Wi-Fi comprises of multiple LED light bulbs that forms a bidirectional wireless network. Let's understand the working of Wi-Fi by this diagram. As you can see here is a light bulb which transmits data embedded in this light. This light is collected and converted by photosensitive detector which consists of receiver and transmitter. This signal is just converted back into electric signal and then back to data. In simple words, it uses modulation of light intensity to transmit data.
So now if we talk about the advantages of Wi-Fi, then at first we can say that it is way more faster than Wi-Fi because it uses light as a transmission mode. Also, since it doesn't need to have any devices such as routers, modems, signal repeaters, etc. So it will save power and hence will have less expenses. Also, nowadays solar energy is being used every day. So using this solar energy and this Wi-Fi technology, we can now transmit data even to the remotest places possible. And it has no interference issues unlike Wi-Fi. Now, Wi-Fi is a short-range device. That means it has a restricted range of operation. So, it will provide more secure data transfer as light cannot even pass through walls or any other opaque objects, unlike Wi-Fi where there always is a chance of users' privacy being compromised, as seen from the image above here. Also, it uses every available spectrum of light for data transmission, so it works on a wide spectrum basis. So, what are its applications? Now, if we talk about this, we can say that the applications of Wi-Fi are actually limitless and are being explored every day. But for citing some proper examples, we can say that it is currently being used in airlines, undersea explorations, operation theaters, hospitals, and office at a very small scale. For example, in hospitals, the blood pressure, the heart rate, etc. of the patients can be monitored effortlessly using Wi-Fi. It is also very handy in business as said. Currently, a grocery store in France is using Wi-Fi to track the position of the customers and give them certain coupons or incentives. Also, Wi-Fi technology is the key to solve the challenges which 5G is facing nowadays.
Like every technology, Wi-Fi also has its own shortcomings. Like here the first point is problem is long transmission through receivers. Light can penetrate water past 200 meters, thus Wi-Fi ability is limited in the seas. Coming to the second point, it is short-range transmission of Wi-Fi. Wi-Fi cannot light is blocked by walls, so coming to the second point, short-range transmission of Wi-Fi. Light is blocked by opaque objects, so light device
Next one.
Light interference. Daylight or any other external source of light can meddle or interfere with
So talking about light interference, so the visible light, the visible light can really interfere with the light coming from the LED bulbs of the Wi-Fi, and so interference could be a problem. Also, light pollution is a very big problem here because the overuse of Wi-Fi and all these LED lights can really create a serious problem for the environment as seen in the image. Also, the establishment cost is higher than Wi-Fi because the technology which is being used to transmit data is still in the development process, and so it is still uncertain whether it will have more devices or it will cost more or something like that. Also, shifting to Wi-Fi from Wi-Fi will be difficult since nowadays people are using Wi-Fi as a transmission mode, so suddenly changing to Wi-Fi will be surely difficult.
Despite its having so many shortcomings, it has a bright future. Wi-Fi is the future of internet since Wi-Fi cannot keep up with our growing internet needs. Also, Wi-Fi is way superior than the Wi-Fi. Coming to the second point, it is advertisement for use street light. Street light can be used to view to show ads for the local business to the passing pedestrians. Now, Wi-Fi for autopilot driving. Vehicle can use back and front light to communicate with the street light or traffic signal for autopilot driving and to increase road safety. Also, almost all smartphones and businesses will use Wi-Fi in the future since they will provide fast connectivity. Since light has a reduced effect on medical instruments, hospitals will use Wi-Fi technology.
So this concludes our discussion on the topic Wi-Fi, and we thank you all for listening to our presentation. If you have any queries, you can ask.
Is there any questions?
Thank you.
Thank you, Abhinav and Bhaktadeep. I request Amay Dev and Bodhisattva Mazumdar to present their seminar on quantum mechanics.
Please take the other mic.
Greetings to everyone. My name is Bodhisattva Mazumdar.
My name is Amay Dev.
And today we are going to give a talk about what is quantum mechanics. Basically, we will try to make you understand that what is quantum mechanics and how it is it can be related to our consciousness and how it can influence to our reality. As you know, in the physical world we live in is made up of atoms, which can be divided into its elementary subatomic particles, that is electrons, protons, and neutrons. So before jumping into the topic, we need to know a bit about quantum mechanics, so that at least people have a glimpse that what we are going to discuss. So basically, what quantum mechanics actually is. So quantum mechanics is a branch of physics which deals or try to explain that how this universe works in such small scale, even smaller than atoms, that is in its subatomic scale. The behavior of the quantum world is beyond belief. Particles being at different places at once communicate at very fast rate, even faster than light. Now it has been past centuries and till the foundation of quantum mechanics, and the physicists are still debating about the fact that how they can depict its equations. One of the particularly weird notion of quantum mechanics is that how quantum mechanics and consciousness can relate with each other and how it can influence to our reality. To know that, we have to understand and experiment. Even some of the founders also thought that quantum mechanics and reality were deeply linked at that time. So we need to understand and experiment. Let us say we shoot some balls like metal. Let us say small marbles, and we let those marbles pass these two slits. We'll definitely see two bands of line which will form on the screen. But instead of shooting all those marbles, we'll shoot a stream of electron, and the result was completely different. They don't show two bands of pattern; they show an interference pattern, a pattern of dark bright fringe, just like this. In the year 1801, this experiment was again conducted by Thomas Young, but instead of shooting all those marble and stream of electron, he did this experiment with a monochromatic light. He projected the monochromatic light and he let those monochromatic light pass through this slit, and the result was similar, same interference pattern formed. So, just like this, and the result would be pretty much similar if the wave of water passed through these two slits, and this kind of interference would form on the screen, as you can see from the slide. Now the further slide of my conditions.
In the year 1947, physicists thought that electrons are somehow bouncing off each other and creating the interference pattern, as you saw earlier. So, in that year, three physicists, as you can see here, they performed an experiment where instead of firing many electrons, single electron was fired repeatedly at a time. So it took more time than the previous experiment, obviously, but it still made an interference pattern like that. And only a wave can make an interference pattern like that, so which suggests that the electrons are now behaving like a wave. Next. De Broglie and Schrödinger in 1924 and 1926 gave the equations of the wave associated with the electrons. This equation, this wave is also called matter wave. Actually. To know what is going on, a detector was placed near the two slits, which would measure, which would detect one of the two slits taken by an electron before hitting the screen. As you can see, this detector is named which-wave detector. But now, surprisingly, instead of making an interference pattern, the electrons made two band of patterns like that. As you can see, two bands of pattern are formed, not like previous interference pattern, which suggests that the electrons are now behaving like particles. Contrary to previous experiment. So, but when the which-wave detector was turned off or removed from this entire setup, the interference pattern would show up. It was as if the electrons knew when we are watching them and when we are not. As you can see, which-wave detector was turned off and video. As soon as the which-wave detector was turned on, the two bands of lines were formed. Now there are some interpretations to this phenomenon. One of the earliest and most widely recognized interpretation is Copenhagen interpretation. It was devised in 1925 by Niels Bohr and Werner Heisenberg.
It tells us that the very act of measurement or observation causes an experiment to settle on a particular result, and that it's meaningless to talk about a well-defined objectivity before that measurement is even made. The Copenhagen interpretations explains the result of double-slit experiment by saying that the electron does not travel as particle or as a wave. Instead, it travels as an abstract probability wave, something we call as wave functions. It means that the state of an electron, that is whether it is a particle or wave, is not determined. But as soon as we make the measurement, as you can see, it shows the particle nature. As you can see, when the detector was placed, it shows particle nature. But the Copenhagen interpretation does not say anything about consciousness. It just says that the measurement collapses the wave function of an electron, and when it does, it shows particle nature like that. But what is the measurement after all? Does measurement take place at the instrument that measures it? Does it take place when the instrument is recording its measurement in the memory, or does it take place when I see the result and the brain interprets the result, or does it take place somewhere in between the above? This is still debates among scientists, and we still don't know the answer. Another such interpretation is called the Newman-Wigner interpretation, which basically postulates that in the long chain of measurement, the collapse occurs at the moment that a conscious, presumably human consciousness, interprets the measurement. In other words, the consciousness of the physicist is making the particle distinct. But this raises all kinds of potential questions about what constitutes consciousness and how is it involved in this process. Can the consciousness of a lizard or a worm also collapse the wave function of a electron? The most fascinating interpretation is many words interpretation. It was given by Hugo Barrett in 1957. It basically states that as soon as we make the measurement, the wave function collapses in our reality, but the wave function continues in another reality where no measurement is taking place. And it also states that there may be infinite number of worlds where no measurement or defined measurement or measurement could take place. In my view, the Copenhagen interpretation is most likely correct. A paper published in 2011 by Shan Yu and Denko Nikoli also show back the Copenhagen interpretation. Their experiment recorded the Huichi information. Huichi information means the information about that which one of the states electron took before hitting the screen. Their experiment measured the Huichi information and recorded it in the state of an atom. Where the physicists are not made where physicists are not made able to this information that whether the collapse occurred or not. But it was, in other words, it was made available to the universe. But this collapse occurred still then. So to sum up, maybe something is watching this collapse, but it does not have to be consciousness. Observation does not have to be conscious. Werner Heisenberg once said, "What we probe is not a nature in itself, but nature exposed to our knowledge of question." Thank you.
We'll take questions. Is there any questions?
Our next speaker is Arnab Ghosh and Rajiv Sinha. I request them to come forward to present the seminar on Webb telescope.
Good morning. Good morning to one and all present here. Myself Rajiv Sinha.
Myself Anand Ghosh from Physics Department.
And today we are here to present a seminar on the topic James Webb Space Telescope. The biggest and the most powerful telescope in the world was launched by NASA, and it is named as James Webb Space Telescope.
So let us know why Webb is launched. So the James Webb Space Telescope, also known as Webb, is a space telescope designed primarily to conduct infrared astronomy. The Webb is the successor to Hubble and is 100 times more powerful than Hubble. So Webb also has a much bigger primary mirror than Hubble. So this large light collecting area means that Hubble can absorb more light than Hubble. This large light collecting area means that Webb can absorb more light than Hubble is capable of doing.
Using this telescope, we can sort of time travel. I mean, it's not possible to go back in time, but we can get a glimpse of history. And I mean, the history which was made millions and billions years ago.
So now let us know some facts about Webb. So the James Webb Space Telescope was launched on 22 December 2021 from Ariane Space Launch Complex at European Spaceport located near Kourou, France, Guyana. It was launched with a budget of around $1 billion with a launch mass of around 6 tons. So the Webb was launched on an Ariane 5 rocket. So the launch site and the launch vehicle was sponsored by the European Space Agency.
Webb is an international collaboration between NASA, European Space Agency and Canadian Space Agency.
So the most special thing about Webb is that it is primarily designed to detect infrared light in space. So the picture on the left, as you can see, the image captured by the Hubble Space Telescope. So as you can see, it consists of space dust and space clouds forming in space. So but the infrared light can pass through the space dust and clouds and is capable to see what lies beyond it. So the picture on the right, as you can see, is as we can imagine what we can see with the Webb. So how big is Webb? As you can see, the Hubble Space Telescope is of the size of an average tractor trailer, while the Webb is of the size of an average Boeing 737. So let us know some innovative technologies involved in Webb. So it consists of folding segmented primary mirror, which is made up of gold, because gold is 98% reflective towards red color. It also consists of ultra lightweight beryllium optics, which can detect extremely weak signals present in space. Microshutters and tricolor are also present in Webb.
Since the telescope worked at a very low temperature, they needed to stop the radiation coming from the sun. To avoid this problem, here you can see the sun shield, which is made up of lightweight material called Captain, and it is in the shape of a kite and as large as a tennis court. So this was basically installed to protect the telescope from the radiation coming from the sun. NASA has said that the entire procedure of creating and launching it is so complicated that they have identified more than 300 potential problems that may arise, more than 300 single point of failures.
So as we know that the universe is expanding, so the light coming from the distant stars, which are millions of light years away, by the time the light reaches the Webb, the wavelength of the light increases, and it tends to be in red color. This phenomena is known as redshift. So let us have some glimpse of the electromagnetic spectrum. So as we know, the visible light is the range of the visible light is in between blue to red color, from which the red color has the largest wavelength. But we know that the infrared light has a larger wavelength than the visible light. So with the electromagnetic wave, the bigger the wavelength, the easier it is for the electromagnetic wave to pass through any object.
You would have seen soldiers using night goggles. This basically detects infrared. Here is the view that you can get using night goggles. So now let us learn what is Lagrange point. Lagrange point are the places where the force acting on an object is perfectly balanced. Lagrange point are the positions in space where the gravitational forces of two body systems like the sun and the earth produce enhanced region of attraction and repulsion. At Lagrange points, the gravitational pull of two large masses precisely equals the centripetal force required for a small object to move with them. Now, types of Lagrange point. There are 5 Lagrange points. L1, L2 and L3 were discovered by Euler. 4 and 5 were discovered by Lagrange. L1. It allows for a satellite to place there to remain equidistant from both Sun and the Earth. It lies 1.5 million kilometers inside the Earth's orbit. L2. This is the location where James Webb Telescope is deployed. L3. It is located on the other side of the system, beyond the Sun. This is the point where the Sun and Earth's gravitational pull align in the opposite direction. Scientists have not yet found any use of L3. L4 and L5. These are extremely stable gravity wells that pull objects into themselves. Certain asteroids known as Trojan fields have been captured at L4 and L5 of Jupiter. L2. This is the location. This is located beyond the Earth, and James Webb Telescope is deployed here. Obviously, because the Earth blocks the radiation coming from the Sun. So here you can see that L2 revolves along with the Earth, and it is very useful because our telescope will remain protected throughout the revolution.
So here we reach our conclusion. So we have always been surprised by what we see in the sky. That's why building a telescope has always been interesting. The universe began with the Big Bang, that occurred 13.8 billion years ago, and this telescope can look till 13 billion years ago. The scientists have been their hopes that using this, they would be able to study how did stars and galaxies form after the Big Bang. So it may hold the key to our survival.
Additionally, it would be very interesting to study about the new planets that this telescope discovers. And here comes the question, can it find a new planet with Earth-like condition where life can possibly be formed? With this note, we would like to end our talk. Any questions?
Yes. You said in the beginning that the James Webb telescope is made up of gold, right?
No, the primary mirror is made up of gold.
Only the mirror is made up of gold.
Primary mirror.
Yeah.
What about the background?
The background, as we have seen, the sun shield. Basically, the sun shield is made up of captain. So that's
What is captain?
Captain is an artificially made lightweight. Means it is artificially made element.
And another question. We have heard about black hole.
Yeah.
What about white hole?
It is just a theory, it is not yet proved. Theoretical.
Thank you, Arnav and Rajiv. Our last speakers are Shubhrati Dev and Saurabh Pal to present a seminar on metaverse.
Get up on this.
So, good morning to all respected directors, principal ma'am, teachers, my seniors, and to all my dear friends. So, myself, Shubhadip Pal from DSC First Sem, and myself, Saurabh Pal from DSC First Sem. Today, we are going to discuss about the metaverse, the next generation reality. So, before going to the topic, these are the contents that today we will discuss. So, what is metaverse? Then metaverse will be social connection, virtual reality, augmented reality, building responsibility, and lastly, metaverse with the future finance. So, what is metaverse? A metaverse is a step towards the digitalization of a new world with a combination of augmented reality and virtual reality. A metaverse is a fresh and vibrant world, which is a newly made world. Previous one, please. Faster. Metaverse is a fresh and vibrant world. It is basically a newly made world with full of energy and with latest concept. In this world, the users are allowed to create their own digital identity. A digital identity is that information which is used by an external agent that may be a people or an organization by creating their avatars, basically an icon or figure which represent a particular person in a game. And then going on adventures, engaging trading, which is the action of buying and selling goods and services digitally, buying property and many more. Social metaverse will be social. Metaverse is the next evolution of social connection. It is basically the new invention of our technology, advancing our technology that we use in our real life. Social connection. A metaverse is a network of 3D space and a virtual world that focus on socialism, infusionism, and science fiction. It lets you socialize with people, learn, collaborate with people, play and stay connected with friends in a virtual world through their digital character that go beyond our imagination. So it is often described that metaverse is an iteration of internet and a virtual world that involves integration between virtual and physical space. An unlimited 3D world that includes such a material that are like computer-based environment, which are virtual economy that includes the significant interest in virtual reality technology.
So here is the video to understand the social connection. Sound She used the metaverse to connect the world. So here is the virtual reality. So virtual reality lets you explore the whole world, share experiences with huge. Even if you are far apart, you can discover with friends and family together. Virtual reality is a explore. Move on. Virtuality is a similar content experience that can be similar to or completely different from the real world. But virtuality is a computer content environment with a screen and object that appear to be real. So here is the video. she used a conversation with another person in metaverse by using this gadget and this also hand gadget. না আইছে না বন্ধই যাবে বন্ধই তো না তো চলবো অটোমেটিক চলে যাবে তাই তো আমি ব্যাক করব এরপর তাই augmented reality augmented reality lets you explore the whole world with share experiences with virtual effects swap effects with the screen and but augmented reality I don't know augmented reality through photo video AR lets you enhance the shared experience with playful virtual effect at swap of the screen, letting you experience yourself with the people who matter most. So, augmented reality is the enhanced version of the real world. Augmented reality is the that is achieved through the use of digital element or sound or stimuli delivered by technology. So, video. So okay. So gaming, building responsibility. Gaming experience will become much more flexible. User can add to the virtual world, create their own content, build some game within a game. Essentially, treated the game environment as a platform, like a space for other activities. So here's the gaming video. So. Beat Saber is an amazing game in VR to so she plays this game and this game is very popular. Used to be a game. So the next and the last topic is the metaverse and the future of finance. JP Morgan on the metaverse. JP Morgan said it is in the metaverse to explore the many opportunities it presents for consumer and brands alike. Metaverse will likely infiltrate every sector in some way in the coming year, with the market opportunity estimated at over 1 trillion in yearly revenues. So thank you for giving us. If you have any questions,
in front of your eyes.
So, ma'am, can I explain in Nepali? तो मतलब मैं এটা সব সময় তো ইউজ করা যাবে না একটা লিমিটেড টাইম পর্যন্ত ইউজ করা যাবে আর যেটা কি আমরা মতলব মানে সাধারণত যেকোনো মানে কি বলবো মানে এই যে লেডিটা ভিডিও মতলব এখন প্রেজেন্ট করা হলো মানে তিনি পুরো 24 ঘন্টা পর্যন্ত এই ভিডিওতে হ্যান্ডসেট ইউজ করেছেন পুরো নন স্টপ ইউজ করে তিনি বলেছেন যে না এটা হতে পারে এটা ভালো হতে পারে কিন্তু হ্যান্ডসেটটা একটু হালকা আর একটু কমফোর্টেবল মতলব হ্যাঁ
Technology will improve over time.
Now another YouTuber this handset use 100 days. 100 days he don't मतलब वो खुले नहीं था handset जगह चलो और non stop ये handset पड़े और खाना बने सब कुछ पड़े
But I think these 100 days are not our real 100 days. Those are 100 days in metaverse.
Yes, the metaverse is share 100 days cutting মানে real days से 100 days যেরকম metaverse same 100 days
metaverse এর একদিন আর real একদিন same হয়
হ্যাঁ তারপর আরেকটা কোশ্চেন আছে metaverse কে নিয়ে the question is that recently like
1.5 months back, a lady was raped on when she was using metaverse. What do you have to say about that? She was molested. So, what are the how safe is this universe that is being created?
তো টেকনোলজির দিক দিয়ে দেখতে হলে এটা একটা বিয়ন্ড মানে ইন্টারনেটের একটা বিয়ন্ড জিনিস, কিন্তু আমাদের হেলথ বা অন্য কিছু দেখতে হলে তো এটা আই থিঙ্ক এটা অত বেশি ভালো হবে না। কেন যদি আমরা সারাদিন ঘরে বসে থাকি আর সারাদিন ঘরে বসে এই হ্যান্ডসেট ইউজ করি তো আমাদের স্বাস্থ্যের পক্ষে অত বেশি ভালো হবে না, আর এনভায়রনমেন্টের তো ভালোই হবে না। কেন আমরা এরকম যদি অনবরত ইউজ করতে থাকি আরো প্রচুর পরিমাণে ওয়েস্ট ক্রিয়েট হবে, অনেক কিছু হবে যা মানে এনভায়রনমেন্টের প্রতি ভালো না, কিন্তু ইন্টারনেট তো এটা অনেক অনবরত ক্রিয়েট হয়ে যাচ্ছে আর ক্রিয়েট হবেই, তো এটা মানে বিয়ন্ড দা ইন্টারনেট বলতে পারেন এটা।
Thank you.
Thank you everyone for your kind presence. Our next shift of the program will start from 12:30 in physics lab.
Thank you, Disha.
Thank you, Disha.